Hi everyone. Today we are going to talk about how to use the chain rule to find derivatives. So you got to be able to do two things: recognize when it's the appropriate time to use the chain rule, and then also apply the chain rule to find derivatives. You will see us use the chain rule whenever we have formats that you see below in A, B, C, and D. Let's say I have something raised to the second power, a quantity raised to the third power, to the sixth power, and the square root. Now we have already used other methods to find derivatives of something like a or b. We've multiplied out 2x plus 5 two times, multiplied that out, and then found the derivative from there. But the chain rule is a way to find a derivative without having to do that. And it makes it really nice when our exponent is not a 2 anymore, but maybe a 6, because I do not want to multiply 2x plus 5 6 times. Or if our derivative, to find the derivative of something with a radical. So let's look at the definition of the chain rule and how it works, and then we'll practice. So right here in the box, we've got the chain rule and how it's defined, and we will work with this definition here. And you'll see me use lots of color coding today. And it deals with finding the derivative of an outside function and an inside function. So let's say I have the function f of g of x, a composition of functions. So we're going to say g will be our inside function and f will be the function on the outside. So if I want to find the derivative of f of g of x, then the way I'm going to do that is I will take the derivative of the outside function and then multiply it by the derivative of the inside function. The only thing we have to keep in mind is when we take the derivative of the outside function in, we just copy down whatever's on the inside. So there's an example in the box right below worked out for us. So my original function is f of x equals 2x plus 5 quantity squared. So we'll define the outside function to be the parentheses squared and the inside function to be the 2x plus 5. So we'll take the derivative of the outside function, which is going to involve looking at the 2, bringing it to the front, and subtracting 1 from the x outside. So that's what's happening here. We've brought the 2 exponent down to the front, subtracted 1, and then we just copy down whatever that inside function is, and then you multiply it by the derivative of the inside function, 2. Now we will practice this a couple of times. Let's see. Let's look at example 1. If f of x, well, that zoomed out really too far. If f of x is 2x plus 5 to the third power, we're going to find f prime of x with and without the chain rule. Well, we're not going to completely find it without the chain rule, but we'll look at it. If I don't use the chain rule, our previous methods that we've learned in other lessons, that would mean I would need to multiply out 2x plus 5 3 times. When I multiply the first two parentheses together, because I can only multiply 2 at a time, I would get 4x squared plus 20x plus 25, and then I would need to multiply that by 2x plus 5. Now I have not even taken a derivative yet. I'm still multiplying all this out. So there's still more work to be done. Keep multiplying and then find a derivative. That's already taking too much time. So then let's talk about how we would do this with the chain rule. So I'm just rewriting my original function, f of x equals quantity 2x plus 5 cubed. The outside function, in this case, is going to be the parentheses cubed. And the inside function is going to be 2x plus 5. So when I go to find my derivative, the chain rule says we take the derivative of the outside function first. So I'm looking at the green. That's the parentheses. If I bring the 3 to the front, I'll have 3. Subtract 1 from the exponent, and I get 2. So that is the derivative of the outside part. Then there's parentheses here. I just copy that 2x plus 5 right inside. I don't do anything to it. I just bring it down. But then I multiply that expression times the derivative of the 2x plus 5. The derivative of 2x plus 5 is 2. So I copied down the 2x plus 5, and then I multiplied by the derivative of 2x plus 5, which is 2. Then I can simplify this just a little bit more to get 6 quantity 2x plus 5 squared. And I would not simplify any further than that. I would leave it just like that. Now, you'll see different times to use the chain rule. So when do we need to use the chain rule? You're going to see 4. Actually, today we'll just see 3 different times we'll use the chain rule, and then this trig power expression we'll see another day. So the first scenario is when I have some expression raised to a power. It looks like I'll need to write this. So I'll have some expression raised to a power. Well, that is like what we just did, the example we just did, where we had 2x plus 5 raised to the third power. So there, the outside function will be the parentheses to the power, and the inside function would be the expression. Whenever we have a root of an expression, the outside function is the root. The inside function is the expression. Whenever I have a trig expression like sine, cosine, or tangent, my trig function is the outside function. And my inside function is the expression. So let's work on the expression to a power. We'll do a few of these. Example 2, 2x plus 5 raised to the 10th. In this case, the outside function is the parentheses to the power, and the inside function is the 2x plus 5. So when I find the derivative, it's a little thick. Let's decrease that. Okay. When I go to find the derivative, I take the derivative of the outside part first. So this 10, bring it to the front. 10, parentheses, subtract 1 from 10 to get 9. That is the derivative of the outside function. Then I just bring down the 2x plus 5. And then I multiply by the derivative of the inside function. So the derivative of 2x plus 5 is 2. So I'll grab my green. And then I'll simplify my whole thing. I can't multiply the 2x plus 5 to the 9th because order of operations say you need to multiply 2x plus 5 9 times before I multiply it by the 10 or the 2. But I can multiply the 10 and the 2 together to get 20 times 2x plus 5 to the 9th power. And there's my derivative. You might see some, like example 3 right beside it. It doesn't look like there's an expression to a power because I've got a fraction, but I can rewrite this fraction as a negative exponent. So I can rewrite that as 2x minus 5 to the negative second power. And so now my outside expression is the parentheses to the negative 2, and my inside expression is 2x minus 5. So when I find the derivative, I'm going to find the derivative of the blue part first. So bring the 2 down to the front, or negative 2 to the front, negative 2. I subtract 1 from the exponent to get negative 3. Then I just bring down what's inside, and I multiply by the derivative of the green part too. So then I'll highlight everything. Derivative of the outside part, and then inside part times derivative of the inside. Simplify everything. I get negative 4 times 2x minus 5 to the negative third. And I can also write my derivative with positive exponents. So that's also the same. Oh, I'm writing f to the negative 1. These are all f primes. F prime of x, f prime, f prime. Let's see, negative 4 over 2x minus 5 to the positive third power. I write it with a positive exponent. Just checking to make sure I didn't use the wrong notation. Yeah. Let's do one with a fraction. So let's look at 5. For example, 5, my outside expression will be the parentheses to the 1/4. So this is the outside expression. And then the inside expression is the negative 4x minus 3. So when I find dy dx, derivative of the outside part is 1/4, parentheses, subtract 1/4 from the exponent, I get negative 3/4. And then for the inside part, I'll bring down negative 4x squared minus 3, and then multiply by the derivative of the inside. Derivative of negative 4x squared minus 3 is negative 8x. Then I can simplify my expression. Negative 1/4 times negative 8 is negative 2x times negative 4x squared minus 3 to the negative 3/4. And if I want to write it with positive exponents, just move that quantity expression to the denominator. Negative 2x over negative 4x squared minus 3 to the 3/4. Now let's talk about what to do whenever you see the radicals. I'll zoom out so you can see where we are on the page. For the problems that have the square root of an expression, what you'll want to do there is you'll want to rewrite those expressions to be in the form parentheses of your expression. I'll abbreviate express because I'm out of space, to a power. So we're going to make these look like the ones from the previous section. So let's start with number 8. I have y equals 2 times the cubed root of negative x squared minus 6. I'm going to rewrite that before I find any derivatives. I know the cubed root is the same as to the 1/3 power. So this is 2 times negative x squared minus 6 to the 1/3 power. So this time, my outside expression is the 2 and the parentheses to the 1 power. And my inside expression is negative x squared minus 6. So let's find dy dx. Find the derivative of the outside part. I'm going to multiply 1/3 times 2 to get 2/3. Parentheses. Subtract 1 from the exponent, negative 2/3. Now it's time to work on the inside. On the first one, just copy it down the same way that it is, and then multiply by the derivative of the inside part. So negative 2x. I can simplify that, and I'll have my derivative. So that would be negative 4/3 x times quantity x, negative x squared minus 6 to the negative 2/3. That is the derivative. I can stop there, or I could simplify with positive exponents. Now let's look at some trig derivatives. Recall from the previous lesson that we looked at these, go back down, go back. There we go. Recall the trig derivatives. These were the derivatives we worked on in the last lesson. I told you to start memorizing them. Now we're going to start to see trig derivatives with the chain rule. So in the last lesson, every time you had to take the derivative of sine, cosine, or tangent, or secant, or cosecant, or cotangent, it was all just sine of just x, just x, just x, just x. Now it's not going to be just x. Now you might see sine of like x squared, or cosine of 3x minus 4. There'll be more of an expression inside that trig argument. So then here is the rule that we're going to look at. We'll keep the same derivatives. The derivative of sine is still cosine, derivative of cosine is still negative sine, and so on. But we do have to change it up just a little bit if we have anything other than just x. Whenever you take the derivative of the sine of something, its derivative is cosine of that same thing times the derivative of that thing. And it works out the same way for all the others. So if I want to take the derivative with respect to x of the cosine of something, that would be negative sine of that thing times the derivative of that thing. So here, let's look at number 10. F of x is equal to 2 sine of 5 plus x cubed. Here, my outside function is the 2 sine parentheses, and the inside function is the 5x plus 3. So I'm going to start with my derivative, f prime of x. The derivative of the outside function, I'm looking at 2 sine. Derivative of 2 sine is 2 cosine of something. I'm just going to bring down whatever I was taking the sine or cosine of. So just bring down 5 plus x cubed. But then you have to multiply by the derivative of 5 plus x cubed. So I'm going to multiply by 3x squared, the derivative of that x cubed. So then if I write this all as one expression, I can't multiply 5 plus x cubed by anything because that is within the argument of cosine, but I can multiply 2 and the 3x squared together to get 6x squared cosine of 5 plus x cubed. We'll do another one. Let's skip over to number 12. F of x equals 8 cosine of x minus 1. So this time, my outside function is 8 cosine parentheses, and my inside function is x minus 1. So when I go to find the derivative, The derivative of cosine is negative sine. So the derivative of 8 cosine is negative 8 sine, parentheses. And then I just bring down whatever's in the parentheses and multiply by the derivative of what's in the parentheses. Derivative of x minus 1 is x. I think it's kind of interesting on things like 13, where we have secant, cotangent, and cosecant. So let's look at 13. I have my outside function to be secant, parentheses, and my inside function is the 3x squared. So let's find the derivative. But I look in my table and I see that the derivative of secant is secant tangent. There's 2 parentheses when I take the derivative. Guess what? That 3x squared goes into both of them. 3x squared here, 3x squared there. Just copy it down twice. Then you multiply by the derivative on the inside, 6x. Don't let that trip you up. Same thing with 14, cotangent of 3x squared plus 2. Hope I'm not making you guys sick. I see that the inside is the 3x plus 2. The outside will be the cotangent. So when I find the derivative, the derivative of cotangent is negative cosecant squared of something. So I just copy the 3x squared plus 2 down, and then multiply by the derivative of the 3x squared, 6x. The last thing we need to talk about are table problems, which throw a lot of students off because they're tables and not expressions. They're not that bad. So take a minute, pause this video, and add this chart into your homework. Not into your homework, into your notes. We're going to use this chart to find h prime of 1 in simplest form. And we should also note that h of x is equal to f of g of x. So take a second, pause, and add this into your notes, and then we will work it out. So to find the derivative of h of x, I see that there's an outside function and an inside function. The outside function is f. The inside function is g of x. So that means the derivative of h is the derivative of the outside function f prime. Then I bring down the inside function, g of x, and I multiply by the derivative of the inside function, g prime, which is also the formula for the chain rule on the previous page. So now if I'm trying to find h prime of 1, I need to find f prime of g of 1 and multiply it by g prime of 1. So this will take me a couple of steps. F prime I can't take yet, so I'm going to find g of 1 first. So g of 1, I go to my g column, and I see that at 1, g of 1 is negative 7. And I can also find g prime of 1. When x is 1, g prime of 1 is positive 7. Now I'm not ready to multiply just yet because I still have to find f prime of negative 7. F prime of negative 7, go to f prime at negative 7, is negative 4. Times 7. And so now I'm ready to multiply h prime of 1. Negative 4 times 7 is negative 28. So that is our lesson today. Hopefully by the end of this lesson, you will be able to recognize when you can use a chain rule and apply the chain rule appropriately to find our derivatives. Let me know if you need help with anything. Have a great day.